Hello, friends. Thanks to everyone at home today who I'm talking to. It is good to connect with you all. This is Mr. Barron here, which you probably know if you're in the Heron version of our course. If you're in the Riverside version, hey, what's up? For today's online assignment, you're going to need the following things. You are going to need something to write with, a pen or a pencil, or my class has whiteboard or expo markers. Feel free to use that. And you are going to have to open up this 4.2 evaluating your Catapult IP, which is actually going to be due at the end of class today is what we're shooting for. Today, we're going to try to finish up our assignment in class so that you can spend a little bit of time outside of class continuing to think about what your Catapult is going to be like. When we started this unit, we posed the question, which one is the best? If you were to take a look around the room right now, or when you're in class next, you'd probably notice that almost everybody has a different Catapult design. We started by talking about prosthetic arms and noting that there's a lot of different varieties of what they look like. And we posed this question of how do we actually figure out which one of these is, in fact, the best, or maybe that it works in the way that we would hope it does, right? The answer, my friends, is to test it and figure it out, which is really what today's class is asking you about. How do we test a design and evaluate whether it meets the requirements we want to or not? And how do we actually go back and decide whether this thing is any good, whether it's better than the alternatives that we've looked at so far, especially when we have so many different designs from each other. So those are kind of the two key components that we're going to work through today. The first argument that I want to make to you today is that some tests are better than others. We want to prove something that works. I want to know that some tests are better than others. A couple of times during this video, I'm going to ask you to pause it and to write down some notes or ideas to yourself and then continue watching it at that point. So when I'm done saying this sentence, you can go ahead and pause your video. And I want you to think back to the paper airplane and the bridge projects that we did in class. What was an effective test you ran on your paper airplane or bridge? What was a test that actually told you something important? And what was a test you ran that you didn't think actually proved that much? Maybe it wasn't actually that helpful for deciding whether it worked or not. Pause your video for a minute or two, write down the answers to those, and then come back to kind of review together in just a moment. Okay, you've unpaused your video. And I want to think a little bit about maybe some of the tests that had to do with like the paper airplane. When I was reading papers from this, I saw a lot of things like it flew or it flew well, or maybe it was successful. And I consider that to be what's kind of like a meh test. It doesn't really tell us that much about whether this thing meets the requirements and whether it's meeting the needs that the user has. But some that might be stronger might be some like those over here on the right. It could support 8 paper clips while it flew, or it flew 10 feet in 3.3 seconds. That's a lot more descriptive to us at telling us whether the needs are actually met. And I think it's really important to take a moment to think about where we actually use testing to tell us things in society, right? Think about when you're applying to college. We could just, you could apply to your college and you could just say something like, hey, I made it through high school. And that's definitely a big accomplishment, but it doesn't really tell them that much about like what you know and where your strengths are and where you might need a little bit of help as you're going into college. So you submit a transcript, which has a more better set of information, some numbers and some specific subjects that tell the college admissions committee what you actually know about when you get to that point. In this way, grades are definitely not a perfect reflection of what you understand, but by having a little bit of a test here, we can make more sense of it. Or another example I thought of is the current COVID crisis. We're going to be testing a lot of vaccines in the next couple of months. And you could just go put a vaccine in someone and then kind of watch them and then, say like, oh, it looks like they didn't get sick, which is one way of doing it. But I think it's better when we can go back and we can look at things that are a lot more specific. I bring these examples of strong and weak tests up because I think there are some things that all strong tests have in common. The first is that they fulfill a specific need. For example, maybe with our airplane, it needs to travel far. They have a metric, which is something that can actually be measured. They say what you're measuring about, whether that's distance or time or speed or how many books you can stack on something. There's a way of measuring something, which we call a measurement. It might be a number of meters, it could be a number of seconds, it could be an amount of weight, or it could even just be like the number of something. Maybe like the number of books, for example, in our bridge drawing that we did. And it has a measurement goal. What will the measurement be if this thing is successful? I would argue that it could be something like 10 meters for this. If you wanted to run a successful 100-meter dash, maybe it's 20 seconds. If you wanted to have a successful bridge for your project, maybe it's 5 textbooks. And when you've written these 4 components out, which I oftentimes like to do in a table, then it's kind of nice to string them together into a sentence that describes the entire thing. To travel far, I will test the distance the plane will travel from where it is thrown. The goal is for the plane to travel 10 meters. Feel free to pause the video here if you want to look at an example of an effective test. But I'd like to practice a little bit here. I've got 3 examples of tests up on the board. I'd like you to go to pause your video, and on your paper, decide whether these tests are effective. And feel free to click play to see what I think the results are when we're done. For test number 1, remember the 4 things that we're going to look for that could be nice to have in front of you is need, metric, measurement, and goal. Need, metric, measurement, and goal. We can find our need right here, which is that it launches a certain distance. But then it just kind of says we will launch a ball and observe it, which doesn't really tell us how we're measuring this. Is there a certain distance we're going to look at? Is there a number that we're shooting for? What units are we going to use to observe this? So I think that this one really only has like one of the 4 requirements. And I often find when I'm looking at student examples that they do a pretty good job of identifying the need, but they don't have that kind of specific element to it. Let's take a look at example number 2. To test the paper airplane, we will see how far it travels and measure it. So when we write, we will see how far it travels and measure it. Like our last example, this actually has a little bit of a metric. We're going to see how far it travels. We're going to measure that. But we don't have a goal that's present here. We haven't given a specific number of meters. And even at the beginning, we haven't really explained the need. Why are we testing this paper airplane? What do we really want it to do? Maybe traveling a far distance is an important part of having a paper airplane. Take a look at number 3. To meet the bridge's need of carrying weight, there's our need. We will measure the weight it can hold by placing textbooks of equal size on top until it breaks. That's a metric and a measurement. We're going to measure the number of textbooks. Our metric is the weight that it can hold. And we've got a goal at the end, that's 10 textbooks. Example number 3 is a nice, strong example of how to actually go through and identify whether a test is effective or not. Feel free to jot these down. 1 and 2 are missing things on here, but 3 is feeling pretty good to me. Once you've jotted that down, follow along with me for a moment. And I'd like you to take a look at your 4.2, evaluating your catapult with testing IP. If you look at the top, everything I just summarized about what makes an effective test is here on this first page. And I'd like you to try some activities on your own that we can check in with. Part number 1, are they good tests? I've given you 3 examples of tests here. 1 for a blender, 1 for a robot, and 1 for an automatic homework calculator. And in the box for each of these 3, I'd like you to explain, do they meet our 4 requirements of a good test? See what you can identify for that. Next, I'd like you to try to write tests for your catapult. Now that we actually have the needs of our catapult, The Catapult needs of what you're going to look at are distance, accuracy, and the amount of weight lifted. The three things that we want to test are distance, accuracy, and the amount of weight lifted. Make sure you're looking at your second test right now. Think about how you would actually test your Catapult in each of these three ways. What metric, measurement, and measurement goal would you give to measure the distance that it can throw a ball, the accuracy that it has as it does that, and the amount of weight that it can lift? And once you've set up those pieces within the table, for each of them in the block that says a sentence, do what we did before and try to summarize them in a sentence. So right now, to start, you're filling in part 1, are they good tests? And part 2, writing tests for your Catapult. We're actually going to give you some feedback on this about halfway through class. You should see that this is the end of the first video for today. You can go ahead and pause your video and complete these 2 things. And when you're done, continue on to the second video in the playlist, where we'll talk a little bit about what we call decision matrix.